Can a machine truly understand passion? Can a piece of code actually predict the outcome of one of the most intense rivalries in all of sports? Well, today, that's exactly what we're going to find out. We are putting AI to the ultimate test, using a whole mountain of data to forecast the legendary clash between Liverpool and Manchester United.
Ah, the Northwest Derby. I mean, just saying the name brings up these images of screaming fans, last-second goals, and those bone-crunching tackles, right? When Liverpool and Manchester United face off at Anfield, it's so much more than a game. It's a clash of history, of pride, and just pure, raw emotion. But what happens if we strip all that emotion away? If we just look past the expert opinions and all the fan superstitions? We're asking a pretty simple question here. In a match that's defined by its unpredictability, what do the cold, hard numbers actually tell us? All right, let's get into it. Now, to build our prediction, we've got to start with the fundamentals. We're not jumping straight into the super complex AI just yet. First things first, we need to lay the groundwork with some classic but really powerful statistical models. So our first building block is something called the ELO rating. If you're a chess fan, you'll know this one. It's actually a pretty simple, elegant system. Every team has a score. When you win, your score goes up. You lose, it goes down. But here's the crucial part. Beating a really strong opponent gives you a way bigger boost than beating a weak one. It's basically a live measure of a team's real competitive power. So what's the ELO story right now? Well, it's a pretty clear one. Liverpool clocks in with a rating of 1631.4, while Manchester United is sitting at 1550.5. That's a pretty significant gap, over 80 points. So right off the bat, this one simple metric is already telling a story of two clubs on very different paths. Okay, next up we use a tool called Poisson Regression. Now I know, it sounds super complex, but the idea behind it is actually pretty straightforward. It's a statistical method that's specifically designed to predict how often something happens. In our case, scoring goals. It looks at things like a team's attacking power, its defensive record, and of course that all-important home advantage to forecast how many goals each side is likely to bag. And wow, the power of that model gets crystal clear when you see these results. Based on all those factors, the Poisson regression predicts Liverpool, playing at home, will score an average of 3.33 goals. Manchester United, on the other hand, they're expected to score just 0.88. So the data is already painting a very, very one-sided picture. All right, so now we move from that statistical foundation right into the world of artificial intelligence. I want you to think of these next three models as a panel of different AI experts. Each one has a totally unique way of looking at the game and offering up its own prediction. First up is the random forest. And honestly, the name is a perfect description of what it does. Imagine you have hundreds of simple little decision trees. Each one looks at a random slice of the data and makes its own guess. The random forest model then just combines all those hundreds of guesses and goes with a majority vote. It's pretty much the AI version of the wisdom of the crowd. And what does that AI crowd think? Well, it is overwhelmingly in favor of a Liverpool victory. It's giving them a 72.7% chance of winning. A draw is seen as a possibility, at nearly 20%, but a Man United win, that's considered a real long shot, at just 8%. Our second AI expert is a gradient boosting machine, or XGBoost. Now, if the random forest is a crowd of independent experts all shouting at once, XGBoost is a team that actually learns together. The first model makes a prediction. The next model looks at the mistakes from the first one and tries to correct them. This process just keeps repeating, with each new model in the chain getting progressively smarter and more accurate. Now, this is where it gets really interesting, because the XGBoost prediction is both similar and different. It still heavily favors Liverpool at 72.6%, which is almost identical to the random forest. But look at the other outcomes. It gives less of a chance to a draw and a slightly higher chance to a Manchester United win, bumping that up to 12.2%. It's a subtle but pretty important difference in perspective. Okay, our final AI pundit is the neural network. This is the big one. This model is designed to mimic the human brain. It's the best of the bunch at finding those deep, hidden, really non-obvious patterns in the data. It might see a connection between, say, a specific set of player injuries, their recent form, and historical results that the other models just completely miss. And the pattern this brain finds is, well, it's one of absolute dominance for Liverpool. The neural network is the most confident of all our models, giving Liverpool a massive 80.4% chance of winning. It sees the chances of an upset as incredibly slim, just a little over 7%.
Okay, so we've heard from our statisticians and our panel of 3 different AI experts. They all seem to agree on the likely winner, but they're kind of disagreeing on the exact probabilities. So the big question is, how do we get to a single, final prediction?
This is where the stacked model comes in. The best way to think of it is as the team manager. Its job isn't to reanalyze the game from scratch, but to analyze the predictors themselves. It looks at the predictions from the Poisson model, the random forest, the XGBoost, and the neural network. And over time, it's learned which one tends to be the most accurate in certain situations. It then weighs all their advice to make the final definitive call.
So here it is. After weighing all the evidence, the final probability from our master model lands on a 73.9% chance of a Liverpool win. This is our most robust prediction. It's a consensus view that kind of smooths out the extreme confidence of that neural network while still respecting the overwhelming evidence from all the other models.
But a percentage chance isn't a scoreline, right? To get there, we need one last step, the Monte Carlo Simulation. Think of this as the ultimate stress test for our prediction. We take our goal probabilities and we use them to digitally play the match over and over and over again, thousands of times, just to see what scorelines pop up most often.
And when we say thousands, we really mean it. The AI simulated this exact match 10,000 times. By doing this, we get a super detailed picture of not just who is likely to win, but how they're likely to win.
And here is the payoff. Out of those 10,000 simulations, the single most common result was a 3-0 victory for Liverpool, which happened 9.1% of the time. But look at the other top contenders, 2-0, 3-1, even 4-0. They're all telling the exact same story. The data is consistently pointing towards a comfortable home win for Liverpool.
Of course, our AI isn't just operating in a bubble. So how does this super detailed, multi-layered prediction stack up against what other forecasters out there are saying? Let's, put it into context. This table really puts it all into perspective. Our AI, which is labeled here as SPECTRA, is predicting that 3-0 win with about a 74% win probability. Other sources, they generally agree that Liverpool will win, but with different levels of confidence. Dimers.com has the win chance a bit lower at 67.9%. Forebet.com also predicts 3-0, but only gives Liverpool a 53% chance. So there's a consensus, but our model is definitely on the more confident end of the spectrum.
So after all of that, what's the big takeaway? Well, we've seen how all these different layers of statistical and machine learning models can be combined to create a remarkably detailed and confident prediction for what is famously one of the most unpredictable events in sports. And that leaves us with a really fascinating question for the future. The data says Liverpool should win, and probably win comfortably. But we love football precisely because the data can be wrong, because anything can happen. So as these predictive models get more and more accurate, what does that change for us, the fans? Does it enhance the experience? Or does it maybe take away a little bit of that magic of not knowing? It's definitely something to think about next time you watch a game.